Okay, so in electromagnetic induction, the Faraday's experiments were performed. Faraday performed experiments which led to Faraday's laws. That is nothing but electromagnetic induction. So let us consider this simple experiment. Okay, now this is a coil. It is connected to a galvanometer. You can see there is no battery, but still some current that we will see when current flows and when the galvanometer will show some deflection. Okay, that's it. We have a coil connected to a galvanometer. Now here is a magnet. You can see the poles north and south. Now let us consider that at first this magnet is stationary. Maybe however close it is even inside the coil, but when it is stationary, no deflection was observed in the galvanometer, indicating that no current is there. Now when the magnet is pushed towards the coil, see the direction pushed towards the coil, suddenly there is a deflection, a momentary deflection is observed. Okay, when there is deflection in galvanometer, it is a sensitive device. It indicates even very small currents. So there is some deflection indicating some current is flowing through the coil. Now from where the current is flowing? First let us see all the observations and then the reasons. Then when the coil, when the magnet was moved backwards, okay, that time also some momentary deflection was there, but in opposite or reverse direction. So the thing is, whenever we move the magnet, the motion of a magnet, then there is deflection. If we change the direction of motion, there is change in the direction of current. Okay. When the magnet is stationary, no current flows. So it indicates that why this current is there when we move the magnet. When we move the magnet in any direction, suppose we are moving towards the coil, there is change in this flux linked with the coil. Now this is, suppose when it is stationary, there is no change in the flux. When the coil experiences change in flux when we move the magnet. There is change in flux. Due to change in flux, it means that current is induced in the coil. So any direction you move, current will be there, but if you change the direction, current will be in reverse direction. And when it is stationary, means when there is no change in magnetic flux, means that there is no current induced. Now what is induced? We say that is EMF. Okay, voltage is induced due to which current flows. This is nothing but the Faraday's laws. So from this experiments, he proved, and then there are two laws that we have to consider. Second law, so first law is, that I will tell you in words again properly afterwards. So first law is that whenever there is change in magnetic flux linked to a coil, there is EMF induced in the coil. Okay, now on what factor it depends? When the magnetic flux will be more, change is more. Okay, so if you move this magnet fast, means the change in magnetic flux, the rate at which it changes. The magnetic flux depends on that factor, how fast we move the magnet. Okay, so first you can just write down first case, when magnet is stationary, no current flows. Second, when it is moved towards the coil, galvanometer shows deflection indicating current flow. But yes, this current is momentary till we move the magnet. Okay. So, and when it is moved in opposite direction, there's a third point that these are all the observations I've been noting down from the Faraday experiment. When it is moved away from coil, it shows deflection. Galvanometer shows deflection in opposite direction. So see the all observations. When magnetic stationary, there is no current. Okay, that means galvanometer shows no deflection. When it is moved towards the coil, galvanometer shows deflection indicating the current flow through the coil. When it is moved away from the coil, it shows deflection in opposite direction, means there is reverse in the current direction.